Hi, I'm very pleased to have Fanny Chevalier here to talk to us. I met her at the last CHI conference in Atlanta, and I thought that her work was very relevant to what we're doing and what we're thinking about, so that's why I invited her, and she'll tell you all about it. So she will do her presentation, and afterwards we had scheduled a session for more questions. But I think that we should probably use that session to brainstorm about how Ubuntu could use her work to generate some good visualization of our data. So here we are.
Thank you very much. Can you hear me well? Yeah?
Yep.
Okay. So I'm going to present diffamation. This occurred in French as means diff animation, but it's open diffamation is for defamation in English. So it's a system that relies on text animated transition to help users navigate in document histories. So when we write document, or when we, as developers, when we write code, it's very often that we go through plenty of different revisions before providing the last document. And for the technical point of view, the storage of the computation of the changes between different revisions and the storage of these changes is a technical problem that is solved. We all use versioning systems such as SVN, CVS or Launchpad. But the problem is that if we are looking for a specific revision, it remains difficult to find the one of interest if we don't remember about its date, its ID or specific information about it. So one needs to browse the revision history of his document, and to our knowledge there is no system that are meant to ease this navigation in history. So browsing document histories raises one question. So given two different revisions, what is the best transition to convey the changes while going from one to the other? So I'm going to show you an example now. So first, we will just try to figure out what are the changes in this document, and I just switch from one revision to the other. So I'm going to ask you guys to try to figure out how many words change in this paragraph. So are you ready? Here we go. Okay. So does someone know how many words have changed? Do you have an idea? 2? Okay. So let's try with another technique now and just try to understand what changed now. It's the same example. So, okay, now everybody got that actually 4 words have been added in this paragraph. So here we have used a smooth animated transition just to help the user keep track of what is changing between the different revisions. So here is another example, the same task, try to understand what happens without animation, without smooth animation, slideshow. And now with animation. So here in this example, it was difficult because the beginning of both paragraphs is the same, so that without any animation, we could think that something has changed in the paragraph. Actually, the full paragraph has disappeared. So here is another example. Now I will be using colors as well to convey the changes. So in the document, what is in red is what has been deleted regarding to the previous revision, and what is in green is the content that has been added. So let's see an example here. So here it's more easy to keep track of what changes between the revision, but still, as soon as we have the content of both revisions at the same time, it's difficult to read the document and to see more than a sequence of 2 revisions. And if we use smooth animated transition, maybe it makes things clearer to you. Okay? So that's the idea of the technique we propose. Actually, how does it work? So we start from two text revision. When I say text, it can be basically anything. So you can think about code if you want as developers, or plain text or whatever. So it's just about sequence of characters. So let's take two different revisions of our document. And from those two revisions, we build what we call a super document. That is a combination of the both revisions. In the super document, you can see that the red blocks correspond to the deleted content, and the green blocks correspond to the added content. And we have a diff computation at a character level of detail. So that's why it's kind of different of what we are used to for now. So from this super document, we can render the first revision. That is when the animation time is of 0. So we just remove all the content that has been added, that are the green blocks. And to render the second document, when the animation time is of 1, we just remove all the deleted content so that we keep the remaining text and the text that has been added. And in between, we interpolate. So how does the interpolation work? Basically, we have two kinds of different motion the ones can choose to use. First, we have what we call direct interpolation. That is basically a linear interpolation of, from the starting position of a word to its endpoint. Or we have, on your right, the modulo interpolation. That is the motion we can observe in text editors. Actually, when a word doesn't fit anymore in a line, it automatically jumps to the line afterwards if we insert content before this word. So that is a motion we can observe in text editors, and just in our technique, we smoothly animate this motion so that the word is disappearing progressively on one side of the document and progressively appears on the other side. So when a word does choose one or the other interpolation, basically what we want to do is to minimize the distance the word has to travel. So if using the direct interpolation, the distance is lower than using the modular interpolation, we will directly interpolate. There are, of course, a couple of more technical stuff. It's not just choosing the one or the other, because we want to keep, for example, paragraph consistency. So we don't want words in the same paragraph to behave very differently, so that we have some other constraint, and as well for word cut and things like that. But this is the main idea of our technique. So I don't go that far into details. You have the details in the paper. I'm going to present now the whole system we have built around this animation technique. So it's called diffamation. Here is a screenshot of the interface. Basically, it's made of three parts. We have the main document view, where the document is rendered and where the animation takes place. We have a scrollbar to browse the document, and we have the timeline to browse the different revisions of the document. So I'm going to show you right now a video that illustrates the scrollbar. As you will see in this video, the scrollbar is not only used to browse the document, it is also a whole overview of the content of your document. You can see that there are gray lines in the scrollbar. That is actually a miniature of your document. And also it is animated at the same time than the main view. So let's see the video. Keep focused on your left. So we can zoom and pan the document, and we have the sum in the scrollbar that is updated. We can scroll the document. And as soon as we navigate in time, you see that the animation takes place in the scrollbar at the same time as the main view, so that it makes it possible to keep track of changes, even if they occur outside of the viewport. So it might occur when you are looking at a specific zone of interest in your text, that the changes that occur above the viewport provokes some changes in your viewport. As in this example, if we had one line above the viewport, it can make everything go down of one line because something has changed previously, below. Obviously, we don't want that changes that occur outside of the viewport to alter the content we are actually looking at. So we have implemented stabilization technique. So I will show you in a short video how it works. Keep focused on both the scrollbar and the content of the main document. So we navigate in time, and you can see on the scrollbar that some changes occur before the viewport, below the viewport, but the content of the main view remains stable. So we have a stabilization mechanism so that if we are interested in some part of text, no matter what happens far away from this portion of interest, I can still keep track of what's going on on the text I'm actually interested in. So how does the stabilization work? Basically, we are computing the overall motion of the visible words in the viewport, and we compute the inverse motion that we apply to the document. So animated at the same time, it makes the view remain stable. So it is particularly, I'll show you on another video. It's particularly, let me see something. If I keep track of a specific function in my code, and since, we can see if I'm interested in a specific function and I have no means of saying, okay, sorry, maybe you didn't get it, but I can see all my video here. Show you an example. Sorry, the layout is different. Okay, let's assume I'm interested in what happens to, for example, one of the line of text, the code here. I have no mean to keep track of this line of code. On more than 2 specific revisions usually, so maybe I want to see what changes around this specific function or what happens to this text. So if something changes otherwhere, I'm not that interested, but you can see as soon as I navigate in the history, I keep track of my current content. And yeah, that's it. Sorry, it's not, maybe it's not clear, but here we go. So, apart from navigating the document in space, we want to navigate between the different revisions. So here is the interactive timeline, so on top of the image. So for now, let's just focus on the first row. In the interactive timeline, each vertical bar corresponds to a revision of the document, and between 2 different vertical bars, 2 different revisions, there is an overview of what happened in between. So here we can see on the example that the document has grown because of the shape growing, and also because of the dominant green color, but still we can see that there are some red color here that means that something has been deleted. So we have an overview of what happens between two revisions. In this timeline, the more two revisions are spaced out, the more changes happen in between, so that we devote more space for more interesting events. And at a glance, we can see that in this document, at the beginning, there was something very small changes, and afterwards has been something interesting, and we can see at a glance what are the important events in the life of the document. To interact with it, we can use the keyboard. So to switch from one revision to between successive revisions, and making it possible to go back and forth quickly between two revisions. Or we can use the mouse to directly access to any revision. And now we compute the differences between the starting revision, the one we are currently looking at, and the destination revision. So not only we can look at the whole history, but we can also jump between any revisions. So we have seen that it might happen that changes occur outside of the viewport. So one need to access the detail, one needs to browse the document to see what actually changes. The problem is that while scrolling the document, we are focused on the scrollbar and we don't have access to the timeline. So to navigate in time, I would require to go back and forth between my timeline and my scrollbar to access both the changes in space and in time. So we have designed a technique that allows for time navigation while scrolling the document, so that when we drag left and right, we are able to control the animation, actually. So let's see on the video. Okay, so we can still scroll the document, dragging back, up and down, and as soon as I leave the thumb in the scrollbar and I navigate left and right, I can control the animation play, actually, so that I can access the details, I can play the animation how I want, and that still, if I'm interested in different locations in my document, I can just scroll, play the animation, scroll, play the animation. So that makes it possible to combine space and time navigation. Okay, that's it for the interaction and the interface. We have also been interested in the changes themselves. So when we edit documents, it is quite often, especially when we code, actually, that we write something and just in the revision after we delete, we just remove what we've just done before. So in this example, we can see that someone has inserted two paragraphs and one of them has been just deleted in the last revision. So here, in terms of changes, there clearly exists shortest edit path that consists of just adding one paragraph, making it kind of irrelevant to have an intermediate step. Because in terms of changes, it is clear that the last revision is closer to the first one than to the second one, right? So sometimes we might be interested in seeing what actually changed in terms of content in our document and not the intermediate steps. So we have implemented such a mechanism to compute the shortest edit path, and this is presented in the timeline. So whenever it exists the shortest path between two revisions, it is shown on the second row in the timeline. So we can see here that between the first revision and the last one that is zoomed, there is a shortest path, because we can see a path on the bottom row. But actually, in terms of revisions, there has been kind of a dozen of commits, actually. So the visual encoding is the same. That is, here we can see that actually there are no changes between the first revision and the second one, because there is neither green color or red color. So actually, we can see that the sequence of those maybe 10 revisions can be summarized at just one revision with 0 changes. So without such a mechanism and such a visualization, it would have been very difficult to figure out that, yeah, after having saved my documents 10 times, actually, I just end up with the same content. So in this other example, we can see that the sequence of those 4 revisions is just one addition. So we have addition, addition, deletion, deletion, and actually we could have been summarized this by one addition. So the user can focus either on the actual revision history, so by looking at the top row in the timeline, or on the shortest edit path history. So in the first case, we can see at each sequence of revision there exists a shortest path. And if we are focused on the shortest edit path history, we can see all the expanding paths. Okay, so we can see here an example, this video. It's basically the same example. You can see that some changes occur to my document. But actually, if I focus on the shortest edit path, I can see that nothing has changed in terms of content. So it's one way to tell the history, the story of the document, not only in terms of what actually happened in terms of revision, but in terms of content. So this is particularly interesting while coding, as I said before, because yeah, when we are trying to fix a specific feature, we often write code and delete and write and blah blah blah. But at the end, from the first revision, before we started to start this huge feature and the endpoint, there is clearly a shortest path. So it's kind of convenient to be able to see that events. So and I particularly like this example when we are collaborating with people. This is an example of a Wikipedia article, and it often happens what we call an editoire. That is when someone is coming, is writing something, and someone comes just after and deletes what the previous user has changed. And they do it plenty of times in a row, so they kind of fight out. So let's see. No! I want to see them fight. No! Oh, sorry. So here actually we can see that people basically it lasted maybe 2 or 3 seconds, and you have seen 50 revisions, and you got the story of the document. So 2 people are fighting on this document, and it's always the same pattern. And you can see this even without playing the animation, because there is the shortest path that you can see on the second row of your timeline. So this was the system. I didn't go into that much into detail because I want also to talk about what already exists and why it's why our tool is new, in what is new. And also I wanted to tell you about animations. I don't know if I will have time, but I will try. So, as developers, I'm pretty sure you say, yeah, I have my side-by-side view or my all-in-one view, and I'm perfectly fine with that. I can see the details, and I'm not sure that your animation will help me figure out what changed between my document, because there are also drawbacks by using our tool. So, okay, let's focus on what already exists. This is what we call a merged version of 2 documents. So basically here we have both the content of the previous revision and the content of the latest one. And the changes are conveyed with colors. So what has been added is in green, what has been deleted is in red and crossed out. So the problem here, to me, is that first, we focus on 2 revisions. So it's really convenient to compare 2 revisions, but whenever I want to navigate in the history, I will have jumps. If I change from the latest revision to the next one, I will have another change also in my view, because the content will be changing. So we want smooth animation. And also what could be a problem here is that I don't have an idea of what is the layout, either at my first revision or the second one. So I have to rebuild by, if I want to rebuild the first revision, I have just to ignore all the green blocks, and it's not always easy. I mean, if you work on Word and you have track changes and you have all these words that are crossed out, it's not very easy to read your text. So maybe in code it's kind of different, because here we don't have to read the story, but still we can have some drawbacks with the visualization. So this one is really efficient. I'm not saying that we are solving all the problems. I'm using this all the day because I'm a coder as well, and this is perfectly convenient when you exactly know what are the 2 revisions you want to compare. So for the code, it's really easy, I mean, in a way to convey changes between 2 different revisions, because the text is line-based. So we can very easily, as you see on this visualization, make correspondences between 2 lines of code. So here at a glance we can see that 2 lines has been modified, 2 has been added, and a huge block has been deleted. So it's perfectly clear here in this context. But if you are looking at plain text, I mean not code, for example a Wikipedia article, just the changes of 1 word can disturb the whole layout. I mean, if you add a word, maybe all your mental map will be disturbed because it's not the same text you see. Because of reflow, actually, mainly. So for plain text, we have that kind of visualization that is also a side-by-side view. It's here paragraph-based, but still we have a word level of detail, because we can see that it's the words that actually changed in those paragraphs are highlighted with different colors. So the drawback with this representation is that you see we have a list of what changed. It's really nice to have an overview of the whole changes in the document, but still I have to browse my document, and it's not visually conveyed what is different from the previous version to the next one in the document itself. So I have to remember, okay, this is here, to search for this part in my document, and afterwards to figure out what was the best between the previous or how to compare them. So it's kind of difficult. So still, all these visualizations are really nice in a way when you already know about the revisions you want to compare. For a comparison of 2 specific revisions, it's great. But how can you find those 2 revisions? For example, you work on a Wikipedia article, this is the kind of interface you will get. So basically it's a list of what has been changed, I mean in terms of revision, and maybe you have written a paragraph, you want to see who did that, who did remove my paragraph. So you will basically randomly keep 1 revision until you see your paragraph, and using decoding technique or whatever, you will try to find the specific time when the thing has changed. So for browsing history, it's not really solved for now. So there are a couple of work still to get an overview of the history of your document. This is history flow. So in this representation, it's kind of it's the same idea than what you've seen in the interactive timeline in Diffamation. Each revision corresponds to a vertical bar, and we can see the flow of text here conveyed by color. A color is associated to a user. So we can see if the content of a specific author remained in the same place, or if content has been added, or if here we can very quickly see that there has been vandalism because the more content of the document has been deleted. And we can see here the flow of the text. So it's really nice to see, for example, here the moves, something we do not support yet, because yeah, you clearly see what the trend of your changes. But the problem with that is just an overview, so it's not a browsing tool. So you see, okay, it's fine, and now I would like to access to my document, because yeah, it's not text, obviously. So it's not yet, it doesn't support accessing to the videos. Maybe as developers you would be interested in some of my previous works, that is about keeping track of changes in code. So this is not based on text, but we compare the trees, syntax trees, am I right? Yeah, syntax trees. Oh, sorry, it's been a while. 2007, actually. So here it's the same idea, so we can see quite easily if what is the history of my code, but it's not about text, but syntax trees. So, for the contributions of defamation, with regard to the redacted work, is that it combines both overview and details. So it makes it possible to quickly detect interesting patterns, specifically with the shortest path mechanism. We have an interaction that allows for focus with context information accessibility. So you've seen that with the stabilization, for example. So we can remain focused on an area and still have an overview of what's happening around. So that is the third point as well, help keep track of questions of interest. And I wanted to emphasize that in my work I try to design interactive visualization. So in our field there is plenty of visualizations that are just awesome, but they are not interactive. If you want to design some visualization, please keep in mind that there are users at the end. Maybe you're not the audience, you think about the end users because you are some of them, but usually what we see in data visualization is that the tools we just to make a simple action, you have to go through plenty of menus, settings, and whatever. So what I like in interactive visualization is that I usually tend for direct manipulation. So you've seen I have my data, and I use the scrollbar, and I navigate in time in Spy. I just touch my data, and it is really a strong point because I'm convinced that visualization is really a nice tool for exploring your data. So keep that in mind, nice interaction. So I wanted to tell you a little bit about animation. It's not part of my work, but it's just in case you're interested in implementing some smooth animated transition, just a couple of related work and whatever exists here. So in terms of animation, it's nice to animate, but sometimes it can be very, very boring and not nice looking. So it's one of the worst websites ever. It's real, yeah. Yeah, it happens very often actually, even now. So you can use animation, but yeah, in plenty of situations they won't be relevant. But animation can be also very useful. We have seen that with the text. But if we take this example, here is a list of items. If I ask you, I will show you the next step. If again I ask you what changed between the two steps, you will see it will be very difficult, so be ready. So what happened to this list of items? So it's really difficult. If we use animated transition, smooth animated transition, you will see, it's really easy to understand. The animation just lasted 300 milliseconds, and you just got what happened. So the animation, when they are well designed and well used, can be very, very, very useful. So we have animated transition more and more in our interfaces. Here, for example, you all know about that. It's when you minimize a window, you can see that it shrinks and go to the taskbar. So without this kind of animation, maybe you're not, I mean, we are now aware that it will go there, but in plenty of situations, just this kind of animation helps you to remind, okay, what's happening to my data. It's not just an abrupt change in your view, it's just, okay, it went here, so I know now where it is. And even if the animation is really short, it's just yeah, I mean, even if it's really the time is really short, you will understand what happens. So, as for the research question, when you want to have some animation in your interfaces, what are the kind of questions we wonder as researchers? Are they useful? So we have already the answers. There has been a controlled experiment. For example, in this first study, Klein and Bigerson studied the effect of smooth animation for text scrolling. So in one condition, the user has had to read the text loudly, and the scroll was 3 lines per 3 lines, so an abrupt changes but only 3 lines. And in the second condition, it was smooth animation, so smooth scroll of the text. And in the case of smooth animated transition, it was the user made less errors, and also they were faster to read the text. We have also this recent experiment on the metro map of the underground map of London. So the task here was to say how many stops there are between two specific revisions, and you have access both at the overview and the detailed view. And in the first condition, no animated transition, so you can just overview and switch from one view to the other, and in the other, just a zoom in, a smooth zoom in. And here again, the animated transition has been proven to be more efficient because it's much easier to keep the mental map model when you have the zoom in. Otherwise, when there is a change, you can get lost very easily. And also in this study, it's interesting that the time of the animation didn't have such an impact. So you can keep having very short animations, but they will be efficient. So we don't want to wait for ages that, it zooms, and animation, smooth animated transition remain efficient even if the time is really short. So, how to realize them? So, just some tricks if you want to implement that. There are two approaches in your model. So, either you consider your object is kind of a physical object that will be moving, so that you have a specific coordinate, for example, and you just change its coordinate across time. Either you consider a parametric approach, so that you have model representation of your object, and you have a rendering function that will compute the intermediate steps. I'm not sure I'm really clear, but basically, yeah, I would recommend the parametric approach because you know about your initial step, the last step, and you can, depending on the time, you can compute whatever you want, the color, the shape, whatever you want, but still you have your object. You do not modify it, it's just a rendering layer. So we can talk about that in the session, but I don't want to bother you with those details, but just to keep in mind that there's these problems. So to design animations, so what is a good timing? There are issues. What is a good timing? What is a good transition? So if there is an element that moves in my screen, what is a good timing and a good transition to convey the change? So I can just have plenty of intermediate frame. Here the transition is a linear transition. The timing is 1 frame each black seconds or milliseconds. This is linear. There are plenty of different options to interpolate from those two positions. We could have slow in motion. For example, you start going slowly and you reach your position fast. You can have slow down, you can have slowing down, you can have different trajectories. So what's a good timing, what's a good transition? And in the case that my object moves further away, so do I keep using the same number of intermediate frames? Do I prefer that my animation lasts longer? So that are kind of questions you have to wonder when you are designing animations. Okay, there are plenty of other problems when plenty of things are changing in your view, so what should we do? Animate everything at the same time, or animate one after the other. Also changing shape, so what's the good transition between those two, the same element that just changes its appearance. Or also when an object splits, or when an object appears, disappears. So that you have to design a whole animation language around that. So, how to better exploit them? So, I mean, animation are good. Use them as often as you want. It's really a good thing. If they are well designed, they are not disturbing to the user, and they help him keep track of what's going on in the display or whatever. So the new use of the animation, of course, is to convey changes in our tools. So here we have still questions when I say in complex configuration what's the best to do. We do not yet support move. So we have thought about what would be the good trajectory of text that moves, what would it be better to animate moves before, after, or the changes and whatever. So there are plenty of questions, difficult questions, when we try to convey changes between two specific time. So maybe I don't have time to talk about that. It's about, oh yeah, okay, that's right. It's about hidden transition. It's the case when you are reloading your document from when you are collaborating with other people. You are not aware of what changed because you have not seen the document before. Here, for example, I opened my Google Mail and have put a window in front of it, and it refreshes each minute, for example. So when I remove the window, will I be aware of the changes between the last time I've seen my mailbox or not? So it's a case of hidden transition. So just as an example, we are specifically vulnerable. I don't know if it's vulnerable. Sorry for my accent. To change blindness. So here is an example. I will show you 2 images and just try again, sorry, to understand, to see if something changes. Actually something changed, but try to... Okay. Have you seen what changed?
Someone's hair colour.
Colors?
Someone's hair colour.
You see, it's quite huge actually. We cannot miss it. And between, you've seen, I've just hidden the image for 10 milliseconds in between. So even a very small abrupt change in your view makes you forget about what has been before and what is afterwards. So while designing interfaces or whatever, maybe it's something that would be really nice to implement in the new release. So it's to convey changes if some content has been hidden. So if I take my example of Gmail, here is the state of my mail. I change, I do some code or whatever, and I come back. Can you say if something changed? So usually for my mail I'm quite good about that because I know how many emails I have read. Oh no, crap, 20. So you know that something happened. It's not that good example, but yes, if you just look at the view, you just forget what was the content before. And here is abrupt transition, when you still keep, you don't have anything in between. It's kind of easy to see that something changed. You cannot maybe say what changed in details, but you see that there are changes. So just to summarize, the abrupt transition that we have quite often are manageable for the user. So animated transitions are much better, and when we have hidden transition, it's just very difficult. So if you can keep in mind that the content that is changing in your interface is not always visible. So if there would be a means to convey the changes, that would be great. So as for the existing work, there has been something. Basically, the idea is to buffer everything that changes as soon as the user doesn't look anymore at the window. I mean, if the window is hidden. And as soon as I come back to my window, either I have a flashback of what happened, so this is what I do with diffamation, so I'm not aware of what changed, but I can replay the changes. Either I can use persistence, so that is afterglow effect, so you have all the changes in the same view, but with some blur effects or whatever, you are aware of what, when, changed. So as for related work, if you're interested in that, take a look at mnemonic rendering. It has been designed by Anastasia Bezayanos in 2006. It proposes two techniques, and phosphor as well is really nice. It just shows you when you are collaborating with people, you cannot see everything that changes in the interface, but here we can see that someone has changed. There is a feedback of what has changed during these last 2 minutes, for example. So we can see that the slider has changed its position and that checkboxes have been unchecked and the value has changed. So just as a start. So as a conclusion, animated transitions are very useful. They convey changes. They are very useful for rapid exploration. We've seen that in the document history. If you take a sequence of revision and you have a specific sentence of interest, it's really easy to keep track of the sentence because maybe you don't matter of what changed around. And it's visually pleasant, usually not the website, but usually it's nice. As for the diffamation system, we have designed an animation language of the text edits. You will see the details in the paper we can discuss about just later. That is not that obvious, actually. It looks really easy when you look at it, but there are plenty of technical aspects for the reflow and whatever, so it's really an animation language design. And we have the whole system to its navigation histories. For future work, We could use animated transition. That would be great when we are reloading a shared document, Google document, for example. What has changed between the last time I've seen the document? Why not while editing? So instead of having, the text that reflows abruptly when we add a word, why not having smooth transitions? That would be maybe more comfortable for the eye. And as for future work, we want to support more complex operation, specifically the move. That is a huge problem, and that would be great for specifically when developing, because we always move the content, and it doesn't mean we change the content, because we can move functions. So that would be great to see that kind of operations. We could also combine with static diffs. Why not having the classical side-by-side view and animating in these two views, just to take benefit of both techniques. And also we would like to support rich text, because for now our prototype type only supports non-formatted text, not rich text. Okay, I made it. Thank you for your attention. I hope it has been good.
Thank you.